Alright, in this video we're going to look at different units of pressure. Alright, in this lecture there are two things that we're going to do. The first one is we're going to talk about different units of pressure. There are 7 different units here. Pressure is probably the one type of measurement we do that has the most different kinds of units. And all of these units, all 7 of these, are in common use. The usage varies from field to field. Some are commonly used in physics, some are more common in chemistry, some are more common in meteorology. But all of these are very common units that you should be familiar with. So we're going to look at these 7 units. And then we're also going to talk about how to do conversions between units, so you can convert atmospheres to torr and bars to inches of mercury and Pascal to pounds per square inch and so on and so forth. We'll do a group of maybe 5 or 6 practice problems at the end of this video lecture. All right, the first unit that we're going to look at is pascals, and you may remember we talked about this one a little bit in a previous video where we were talking about the definition of pressure, and we said that 1 Pascal is 1 Newton per square meter. And you may also remember that 1 Newton is 1 kilogram meter per second squared. And that means that 1 Pascal is 1 kilogram meter per second squared per meter squared. 1 Pascal is 1 kilogram per meter second squared. Generally speaking, you don't need to remember all of this. I just wanted to point this out because sometimes this can be useful, particularly if you're doing calculations with hydrostatic pressure, seeing the units in there. Okay. And also I want to point out that because this unit is composed of kilograms, meters, and seconds, this is an SI unit, and Pascal is considered to be the standard SI unit of pressure. So that's another reason that it's important. This unit is primarily used by physicists. If you're doing calculations on pressure where you're calculating forces and things like that, this is the most convenient unit to use. It's not really used by chemists very often, but it's important to have this as kind of a foundation, and also to see how it's related to some of the other units. Pascal is actually a pretty small unit of pressure. 1 Pascal is very, very small. So pressures are often measured in kilopascals, and so you'll often see kilopascals. And for things where they're fairly high pressure, you may even see megapascals. Right? I wouldn't consider these kilopascals and megapascals to be different units. They're really just the unit Pascal with metric prefixes added to them. So if you're familiar with the metric system and you know pascals, then you also know kilopascals and megapascals. All right, the next unit is atmospheres. And an atmosphere is defined as being exactly 101,325 pascals. This is important because this is a Pascal is defined as we saw in the previous slide, and this definition, which relates atmospheres to pascals, gives us a precise definition of an atmosphere, and that's a good thing to have. I would say I'm a little bit ambivalent about whether or not I would ask people to memorize this number. I think it's an important number and it's a useful number, so I would like people to know it, but from a logistical point of view, it's a 6-digit number. That's kind of a lot to ask a bunch of people to memorize. So on quizzes or exams, I would probably provide that number to you, but I would still encourage you to learn it because it's important. It's a thing you ought to know. If you're not in my class, then you might ask your teacher or your professor whether they want you to memorize that number or not. The important thing for atmospheres, in more general terms, is that an atmosphere is approximately atmospheric pressure at sea level. In a previous video, we talked about the work of Torricelli with the barometer, and one of the important things that came out of those experiments was the determination of atmospheric pressure. And under normal conditions at sea level, atmospheric pressure is approximately 1 atmosphere. It varies a little bit by maybe a percent or so. I'm thinking about that. No, probably less than a percent, a fraction of a percent, depending on weather conditions. But it stays pretty much around 1 atmosphere. If you're in a city with a higher altitude, then it can be a little bit less than 1 atmosphere. It's useful, I think, if you've got a question in general chemistry. Typically, all of the information will be given to you that you need to solve the problem, including the pressure. But in advanced classes, you may have some more open-ended questions that require you to make some reasonable assumptions. And so anytime you're doing a problem about something at ground level, if it's not in the atmosphere, if something's happening at ground level, a pressure of 1 atmosphere for total atmospheric pressure is usually a pretty good approximation if you need to make that. All right. And from our point of view, the most important thing about this is that atmospheres is the unit most commonly used by chemists. We'll be looking at gas law calculations, and the pressure that's used primarily in these gas law calculations is atmospheres. So that's the one that we're going to use most often. Okay, the next unit is millimeters of mercury, and this, of course, this unit comes from use of the barometer, relating pressures back to barometric measurements. And the pressure, millimeters of mercury, is just the pressure that would be exerted by a column of mercury that's 1 millimeter high. It's pretty simple. The meaning of the unit is pretty much just in the definition of the unit. I should mention also, I didn't mention this on the previous page, I ought to. In each of these slides, we have the name of the unit and then the abbreviation. So when you cite something, you cite pressure in millimeters of mercury, you might say the pressure of something is 123 millimeters of mercury. That's how you'd write it. And we can relate this back to the atmosphere. As I said before, the atmosphere is the unit that we're going to use most often in chemistry. So we're going to try to relate all of the other units back to that. And 1 atmosphere is 760 millimeters of mercury. So this is something that you need to know. I'm going to, at the end of this, after we go through all the units, I'm going to give you a list of things you need to know. But I'll just go ahead and tell you that's going to be one of them. Okay, the next unit that we're going to look at is the torr. And of course, this is named after Evangelista Torricelli, who did a lot of early work on the barometer. And so this unit torr comes from the barometer. Okay. And the unit torr is defined as being exactly 1/760th of an atmosphere. If you look over here, we have this equation here. We sometimes write this with a triple equal sign. So we might sometimes write this way. 760 torr is equal to 1 atmosphere. And the significance of that triple equal sign means that this is an exact definition. And so anytime we use that relationship mathematically, because the definition is exact, it doesn't introduce any error into our calculation. the relationship can be considered to be infinitely precise. Now, this definition that I gave you is essentially the same thing as what we just said a minute ago for a millimeter of mercury, because a millimeter of mercury is also 1/760th of an atmosphere. However, 1 torr and 1 millimeter of mercury turns out are not quite exactly the same thing. They are very, 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 very close to the same thing. And the difference between them turns out to be something like 1/10,000th of a percent. So they're close enough that we can consider, for our practical purposes, that this is a perfect relationship. And anytime you're converting from torr to millimeters of mercury, you can simply say 1 torr is equal to 1 millimeter of mercury, and that's so precise that we can consider it to be perfectly precise. Okay, it is not like this one. It is not actually a perfect definition. There is some teeny tiny difference there, but that difference is so small that we will ignore it and consider this to be effectively infinitely precise for our purposes. All right, the next unit is inches of mercury. This one really, essentially, it's not a new unit. It's exactly the same thing that we just had. Inches of mercury is really exactly the same thing as millimeters of mercury, except that we're using English units instead of metric units. So an inch of mercury is just the pressure that would be accompanied by a column of mercury that is 1 inch high. And if you remember your metric to English conversions, right, 1 inch is 25.4 millimeters, and therefore 1 inch of mercury is 24.5 millimeters of mercury. Okay. That's really not a pressure conversion in a sense. It's really just a metric to English conversion, because all we're really doing is just changing this unit between English units and metric units. Okay. Now, where you'll see this, inches of mercury, we don't really use this in chemistry very often, but you will see this a lot in weather forecasting. Pressure is used a lot in weather forecasting. This is a little graph that came from a weather site. We're looking at the weather in Lynchburg from last week, and you can see the predicted weather up here in this top row. In this bottom row, it's showing two things. The blue down here at the bottom, right? This is the percent chance of rain on this axis over here, and this over here on the far right, this is the barometric pressure in inches of mercury. And the reason that barometric pressure is important is because low pressure is associated with the arrival of weather fronts, and weather fronts usually have rain or storms with them. And so if you observe a drop in the pressure, that's an indication that rain is coming. And if you look at this graph here, you can see on the left, right, there was fairly high pressure throughout this region when the weather is very sunny. Pressure drops, and as the pressure drops, the chance of precipitation increases later in the week. And you can see that here with these storms for Wednesday through Friday. So you will see barometric pressure reported in English units in weather forecasts, particularly in the United States, and it also shows up a lot in chemistry books and quizzes and exams and things like that, because it's a common everyday usage that we see. It's a practical usage that we see, and we should be able to make conversions between this and the other things that we're doing in the class. All right, so the next unit is bars, which just has the abbreviation bar, which is not very, which isn't shorter, but that's the abbreviation that's used for this. And bars are related to pascals, because Pascal is a metric unit composed of kilograms, meters, and seconds. It makes pascals very useful for work in physics, and it would be nice to be able to directly relate pascals to pressure used in chemistry and meteorology and things like that. So what the bar is a bar is based on Pascal, but remember that an atmosphere is 101,325 Pascal. So there's a huge difference between the units of Pascal and atmospheres. So what a bar is it's related to pascals, but it's approximately one atmosphere. So one atmosphere is 101,325 Pascal. If we just round that to 100,000, then that's a bar. Okay? And a bar is defined as exactly 100,000 Pascal. And what that does is it's a unit that's approximately one atmosphere, but it makes conversions between bars and meters, kilograms, seconds type units a lot easier. A bar is about an atmosphere, but it's a teeny tiny bit less. So whereas an atmosphere is 760 torr, one bar is 750 torr. Okay? This is not an exact definition here, but it's pretty good. It's correct to three significant figures. So if you need to convert between bars and torr or bar and atmospheres, you can use this relationship. I think we'll rarely have any data that's precise to more than three significant figures anyway, so this is a good conversion relationship to use. And with bars, with any metric prefix, you can also add, or with any metric unit, you can also add prefixes, and so millibars are also very common, and that's what we saw on that weather barometer on the previous page. Right? So atmospheric pressure is approximately 1 bar, which is about 1,000 millibar. So if you have a slight low pressure on some particular day, then the pressure might be, say, 983 millibars. And those are the kind of units that are used on those dials. That's also the way that barometric pressure is usually reported outside the U.S. All right. The next one, I think this is our last one. The last pressure unit is pounds per square inch. Okay, and this is the unit that's used most often in industry and engineering. And even though it's not a metric unit, not only is it not an SI unit, it's not even metric. It's pounds and inches, so it's based on English. But in this country, even now, engineers almost always report pressures in terms of PSI. You'll see that consistently through those. One of the interesting things about PSI is it's pounds per square inch, so you could write it pounds per square inch like that, but you almost never see that. Pounds per square inch is almost always written as PSI, just an abbreviation for pounds per square inch. All right. One of the places that you'll see it, and one of the reasons that it's important, is this is what's used, in the general public. Anytime you're inflating something like a tire, this is a truck here going to get tires inflated at a gas station air pump, and here's the pump over here. And if you look at the pump, and we're going to look at the tire in a little bit too. If you look at the pump reads the pressure in the tire, and this, it doesn't have any units displayed here, but the units here are pounds per square inch, PSI. Same thing is true if you're inflating a football or a soccer ball or a basketball. The units on those gauges are always going to be pounds per square inch. All right, so we've looked at a whole bunch of things so far. Boils down to what people typically ask: what is it that you need to know? So let's take a look at that. Okay. The most common unit that we're going to be using are atmospheres. So I tried to put together a little table and relate everything to atmospheres here. So you ought to know all of these things, how each of these different units relate to atmospheres. Okay. Particularly, the most important ones that you'll see most often in chemistry are these here: torr in millimeters of mercury. Okay. This one, as I mentioned before, I'd probably give that to you on a quiz or exam if you're not in my class but using this video to study, you might ask your teacher or your professor whether or not they want you to memorize that or not. And this one down here, it's not an SI unit. It's not something that we use a lot in chemistry, but you'll see it so often that it really is an important thing to know. Okay? So that's how all of these things relate to atmospheres. That's important. You should also know the bar that we talked about a little bit before. A bar is defined as 100,000 Pascal. That's an exact definition. That's an exact definition. And that definition makes it approximately 1 atmosphere. All right. So if you're talking about the pressure outside is about 1 atmosphere. You can also say the pressure is about 1 bar. Okay. If you need to actually do a calculation, a good relationship that's good to 3 significant figures, and I just think it's an easy number to remember. 750 is an easy number to remember. 1 bar is 750 torr. So that's a good thing to commit to memory. Okay, and then finally, you should know 1 inch is 2.54 centimeters. 1 centimeter is 10 millimeters, and therefore, I probably should have written this down here. So that means that 1 inch is equal to 25.4 millimeters. Okay? And if you know that relationship, then you can convert between inches of mercury and millimeters of mercury. I don't really consider that a pressure conversion. It's really just more of a unit conversion, but you should be able to do that. Okay. All right. So these are all the things you ought to commit to memory. You ought to have these in your toolkit ready to use anytime you're confronted with any of these pressure calculations. This is what you need to know in order to do the calculations. All right. Okay, so what should you do in order to study this? We're going to talk a little bit about conversions and go through a couple of calculations. But before you do that, as a basic fundamental, you have to know the relationships on the previous slide. Okay? These are not, generally speaking, not conceptual things, but just simple facts they need to commit to memory. And if you're looking at simple facts to commit to memory, then the best thing to do is to make flashcards. And so I would recommend you get some flashcards. And for example, just put on the front, 1 atmosphere is equal to some number of torr. And then on the back, fill that in. 1 atmosphere is 760 torr. You make maybe 8 or 10 of these for the facts on the previous slide. Go through those, and you'll have them in about 5 or 10 minutes. You'll have everything down, and you'll be ready to go. Okay, and you'll have an easy way to review them. So I highly recommend flashcards for these different pressure units. All right, let's dive in and try a sample problem here. This first one says that ammonia gas is synthesized in high-pressure reaction chambers in which the typical pressures can be 15 megapascal or higher. What is this pressure in units of atmospheres? As I mentioned earlier, atmospheres is the unit used most commonly in chemistry. So if we're going to do some kind of a calculation of the number of moles of ammonia in this reaction, we'd probably want to convert this to atmospheres. Now, to do this conversion, we need to know some things about megapascals and atmospheres. We're going to do the calculation using dimensional analysis, and dimensional analysis is based on conversion factors. And conversion factors, in turn, are created from relationships. If we know the relationship between pascals and atmospheres, that relationship gives us a conversion factor. If we know the relationship between megapascals and pascals, that also gives us a conversion factor. So let's write down what we know. We know, based on our metric prefixes, that 1 megapascal is equal to 1 million, or 10 to the 6th, pascals. We also know that there are 101,325 Pascal in 1 atmosphere. Okay. So we can use each of these relationships to make a conversion factor. Okay. Let's take the first one, megapascals and pascals. Remember that the way dimensional analysis works is we make conversion factors by making fractions that are equal to 1. And a fraction that's equal to 1 is anything where the numerator and the denominator are equal. So we could write 1 megapascal over 10 to the 6th Pascal. That's a fraction that's equal to 1. That gives us a conversion factor. Or we could write 10 to the 6th Pascal over 1 megapascal is equal to 1. That's also a conversion factor. Okay. I'm going to go ahead and erase this so we've got a little bit more room. But make sure you've got this written down, because this is what we're going to use for the calculation. All right. Maybe I won't erase it. All right, let's see if I can fit it in. I'm having trouble with my pen. All right, so we want to convert 15 megapascal to atmospheres. So let's go ahead and set up our dimensional analysis. All right, 15 megapascal. And then we'll use this first conversion factor. We can use either the one on the left or the one on the right. We want to use the one that allows us to cancel the units. So we're going to use this one over here. We'll write 1 megapascal in the denominator and 10 to the 6th Pascal in the numerator. And then we'll do a second step to convert between Pascal and atmospheres. So we'll make another conversion factor. In this case, we want pascals to cancel. So we'll write 101,325 Pascal in the denominator and 1 atmosphere in the numerator. All right. And then when we multiply that together, you see that our megapascals cancel, our pascals cancel, and the units that we end up with are atmospheres. If we put this in the calculator and run the numbers, we get 148.03 atmospheres. We go back and look at our significant figures. The information given to us had 2 significant figures in it. Both of these are definitions, so they have, in principle, an infinite number of significant figures. So we should round our final answer to 2 sig figs. So our final answer would be 150. Oops. 150 atmospheres. All right, here's another one. This deals with barometric pressure and weather forecasts. It says the Weather Service Weather Underground reports that the barometric pressure in Denver, Colorado is 25.6 inches of mercury. What is this pressure in atmospheres? Okay. So we're going to do the same thing. We're going to use dimensional analysis to go from 25.6 inches of mercury to atmospheres. And in order to do that, we're going to use dimensional analysis. We're going to multiply by a couple of conversion factors, 2 or 3, whatever it takes. And each of those conversion factors is based on one of those relationships. So let's look at inches of mercury and atmospheres and see what relationships we can recall that might be useful. Okay. Well, one thing we know is that 1 inch is equal to 25.4 millimeters. So 1 inch of mercury is 25.4 millimeters of mercury. Okay. We also know if we can get these units into millimeters of mercury, we know that there are 760 millimeters of mercury in 1 atmosphere. All right. So this will allow us to convert from inches of mercury to millimeters of mercury and millimeters of mercury to atmospheres. Looks like that's really all we need to do this, just those two relationships. Okay. So let's start with what we've got. 25.6 inches of mercury, and then we'll use that first conversion factor. We want inches of mercury to cancel out, so let's put 1 inch. Let's go ahead and write 1 inch of mercury is equal to 25.4 millimeters of mercury. And then let's do a second conversion to get to atmospheres. We want millimeters of mercury to cancel out. So let's write 760 millimeters of mercury is equal to 1 atmosphere. All right. And when we do that, we can cancel. We end up with atmospheres, and if we plug that into the calculator, we get as a result 0.855558 atmospheres. Okay. And if we look at our significant figures, we've got 3 sig figs in the information given to us. This is an exact definition, so that has infinite number of sig figs. This is not an exact definition, but it's very close. Got 3 sig figs here, so we should round this to 3 significant figures. And this would give us 0.856 atmospheres. That's our final result. All right. This third example says the pressure inside a steel nitrogen tank is 755 psi. What is this pressure in bars? So we need some relationships between psi and bars. I don't know any relationship between psi and bars, but I do know that there are 14.7 psi in 1 atmosphere. Okay. So that'll allow us to convert between psi and atmospheres. That won't quite get us to bars, although if you remember, a bar is approximately the same thing as 1 atmosphere. So if we just use this conversion to calculate the answer in atmospheres, we'd have something that's a very good estimate for the pressure in bars. If we actually want to get the pressure in bars, we can remember that 1 bar is 750 torr. Okay. That's helpful. That won't quite get us there because we still need some kind of a bridge to get from atmospheres to torr. Okay. So the last thing we need, I hope you will recall, that 1 atmosphere is 760 torr. Okay. And this will allow us to go from psi to atmospheres, from atmospheres to torr, and then from torr to bar. Okay, so let's write this out. We'll put in all of these conversion factors. Got 755 psi. We use this first conversion factor up here. We want the psi to cancel, so we'll put psi on the bottom. 14.7 psi and 1 atmosphere on the top. Okay, that will allow us to convert from psi to atmosphere. And if we want to go The next step, we want to convert atmospheres into torr. So we recall 1 atmosphere, that goes on the bottom because we want it to cancel. 1 atmosphere is equal to 760 torr. Okay. And then our last step, we want to convert torr to bars. For that, we'll use this conversion factor here. And again, we want torr to cancel, so we'll put torrs on the bottom. 750 torr is equal to 1 bar. Okay. Look at our units. Our atmospheres cancel. Our torrs cancel. And that should give us our result in bars. If we run through the calculation, put those numbers in our calculator, we end up with 52.045 bars. And then if we look at our units, the information given to us here had 3 significant figures. This is an approximate relationship here, which is correct to 3 significant figures. This is a definition, so it has an infinite number of significant figures. And then this one is also an approximation, which is correct to 3 significant figures. So if we look at all of those, it's clear that we need to round our result to 3 significant figures. So that would be our last significant figure. And when we round that, we would get 52.0 bars. Okay, let's just do one more sample problem. That photograph I showed a little while ago with the truck at the tire gauge getting the tires filled up, that was my truck, and this is my tire. I took a picture of this when I was over there, and I'm not sure if you can read it. Probably not, but right here it says max pressure 340 kilopascal or 50 psi. And whenever I see something like that, I think, hey, that's really cool. They've given the pressure for the tire in 2 different units, and I wonder if that math works out. I wonder if 340 kilopascal really is 50 psi. And so, that provides an opportunity to have a little bit of fun and play around with conversions and see what we get. So, again, we need to write down our relationships that we know, whatever we know about psi and kilopascal and so on and so forth. So, just remembering our metric prefixes, we know that 1 kilopascal is 1,000 pascal. Okay, and we know that there are 14.7 psi in 1 atmosphere. Okay. So that allows us to convert between kilopascal and pascal and psi and atmospheres. But in order to complete this, we also have to somehow get from pascals to atmospheres. So we need one more relationship. And with that, we should remember that 1 atmosphere is 101,325 pascal. Okay. All right, and if we know those things, now we can put this together and do the math and see what we get. All right, so we'll do our dimensional analysis. Start with 340 kilopascal. Okay. Use a conversion unit to change kilopascals into pascals. We want kilopascals to cancel, so we'll put that in the bottom. 1 kilopascal in the bottom. is 1,000 pascals. Okay. And then we want to go from pascals to atmospheres. So 101,325 pascals in the bottom, and 1 atmosphere in the numerator. And then to convert from atmospheres into PSI, we know that 1 atmosphere is 14.7 PSI. All right. If we look at our units, we see that our kilopascals will cancel, our pascals will cancel, atmospheres cancel, and we should end up with PSI. Excuse me. And if we just put all of this into the calculator, run these numbers, 340 times 1,000 times 14.7 divided by 101,325. Put all that in, we get 49.326 PSI, which, if we round it to two significant figures, actually 49 PSI. So 49 PSI is actually a little more correct than 50, but they're essentially the same thing. So the numbers on the tire are essentially correct. And they provided us with a little bit of extra fun. Can't beat that. All right, so let's look at what we've done in this video. We looked at units of pressure. There were 7 different units that we looked at: pascals, atmospheres, millimeters of mercury, torr, inches of mercury, bars, and pounds per square inch. Okay, all 7 of those are in pretty common usage, so you should be familiar with all 7 of those and know what they mean. Okay, and then, perhaps in some ways almost more importantly, you should be able to you should know the mathematical relationships between the different units so that you can do conversions and calculations, right? You need all these relationships to get your conversion factors for dimensional analysis. Okay? So 4 of these can be related directly back to atmospheres. You should know all of those relationships, and a good way to work on those is with flashcards. Okay? And then you should also know that 1 bar is 100,000 Pascal. That's the definition of a bar. That's an exact definition. Also know that 1 bar, excuse me, 1 bar is about 750 torr. That's an approximation, but it's a very good approximation. That's correct to 3 significant figures. And 1 inch of mercury is 25.4 millimeters of mercury. Okay, these are 3 extra bits of information that you may need for some conversion factors. So work on all of those, commit all these relationships to memory, okay, and then practice doing some conversions. There are some practice problems to work on in the study guide, and practice doing those conversions using those relationships. All right, that's all we need for this one.